Good day, I'm Reynald Cañatal and I'm going to show you the 4-bit shift register first using DP-flop and JK-flop in a serial in and serial out, and the given input is 1011. So let's simulate this. Here is the schematic diagram, and to get the input 1011 we need to put here first a input 1, and then let's do a cycle. First cycle is this, and as you can see, the one here is registered here, and then the next is 1 again, and then the next is 0. As you can see, the input register is 0, 1, 1 now. Lastly, we need to input 1 and then do a 1, 0, 1, 1. And as you can observe that the cycle, the number of cycle is 4. And then here. Then the next problem here is serial in, parallel out. So the output is in parallel flip-flops. So the code again is 1011. So let's do, here is the schematic diagram, and then let's do the input 1011, which is 1011. So let's input 1 first, and then first cycle, and then to the second cycle 1 again, input 1, and then the next cycle is 0. Last cycle is 1. And as you can see, the output is in parallel to the flip-flops. And then 1, 0, 1, 1, 1, 0, 1, 1. So serial in and parallel out. Then next is 4-bit shift register parallel in serial out using the flip-flop. So the input is in parallel and then the output is in serial. So let's do it in the simulation, and then the code is 1011 to simulate the inputs 1011 and then the 4-bit serial out. And let's look the clock cycle. So here, let's say 1011. The input is in parallel to the flip-flop, and then let's click the clock, and here, so you can see in the first cycle the output is already in 1011 in serial output. So here you only need 1 cycle. And then next is parallel in, parallel out, and the code is 1011, the input, and then let's see the clock cycle, do the 4-bit serial out. Here, let's look to the simulation here. To do this, the input is in parallel, so let's put the 1011, 1011 here, and then let's see when the clock is in high, the output is already in 1011, 1011. So in this circuit, you can do only 1 cycle. The next is the bidirectional data, which is, and then the input is 1101. So here we are going to do the 4-bit shift left register. So from the left side, let's see on the left side, let's click the left DL, and then we're going to input the Let's see this. 2. Let me check again. 1101. Second cycle is 111. And then let's turn it up. Then cycle is 0. And then last cycle is 1. And then 1101. So here you can see that the cycle is in 4 cycle from left side. And then next is on the right register, 4-bit shift right register, and then the input is 1001. And let's see this the cycle needed to the 4-bit serial out. And here is the simulation. From right here, let's click the right, and then first cycle. And and next cycle is 0. So let's turn it up. It's clear. I forgot to click this one. Then from right, click this one here, so you can see 1 0. And then the next is 0. And then second cycle 0. And then the last cycle is 1. So 1 0 0 1. So it also need a 4 cycle to get the serial out. And then lastly, which is this one, you simply flip the 4-bit universal register using the flip-flop. And I'm going to show you the selector in 1-1, and then the parallel load and parallel out. So let's do this in simulation. Then here, set this selector in 1-1, and then it indicates that the input is in parallel. So the code we needed is what again? 1101. 1101. And then let's click the clock here. And then the is in parallel here. Then 1101. And then that's all for the video demo for this register. That's all. Thank you.